Yo, what's up, everybody? Welcome back. Today, we are working on our barcode scanner. Yet again, another day, another barcode scanner day. It never ends. What we have got so far is we have like an image in here. We go and we go, hey, there might be a barcode in there. Where is it? And so we like do some steps to like resize the image to something really low res so that it's cheaper to work with. We do some edge detection on there. We try to like downsample that some more. We look for areas where the edges kind of line up. They're in like the same direction, and we like kind of cluster those things together. So I don't know if you guys can see that red line very well, but we've drawn like a little red box around what we think is like the most likely candidate for a barcode in this image. We pull that thing out. Hype. We used to, assuming we had this, we had some code that basically turned it into this. The idea was that we wanted to know, are areas dark or light? And we thought the original idea was that we could kind of go like line by line and parse the barcode at each line and then gain some like total consensus of what the number was, right? Presumably, at least one of these lines would get the right answer, and hopefully like many of these lines would get the right answer, right? But looking at this, the way that we had the data encoded, I started to realize that this shadow here was going to be a problem. Because as I'm parsing, it's pretty obvious that this is dark. It's pretty obvious that this is dark. This is like, these guys over here, it's pretty obvious that these are dark because you know that like, okay, I'm like between two light sections, right? But here it starts to feel a little bit more ambiguous, right? In this scenario, you could probably find some threshold to bisect darks and lights completely, but like, you could imagine a scenario where it's not like super, super obvious. Like, I don't really know that this color, like maybe like the darkest part of this, like maybe here, I don't really know how far away that is from like the lightest part of here, right? And like programmatically determining what like a good bisection point is when it's not like super, super fucking split is not super obvious to me. And so what I think the more correct answer here is it's really obvious when you look up, like me as a human, when I look at this, I'm so confident that this is light, right? It's like super, super obvious to me. It's like, why? Well, probably because like it doesn't go up and down the whole way, right? We have the context of the whole image. And so what I think the right answer is now is to try to like compress the vertical bars down into like 1 pixel tall, and do the barcode scanning part one time. And so we've kind of been on this mission where we did barcode extraction and alignment here. We're kind of hoping that like the vertical alignment of this is like good enough. We might have to improve it a little bit. I think there's probably a few pixels, above and below here. It's also hard to tell because this particular barcode is on a curved surface, so I don't really know if this is like, maybe this is right. Like, I'm not really sure. But what I want to do today is figure out how to do whatever we want to do, right? So I'm thinking my current idea, which I have not thought about very hard. Let's be clear. We don't think around here. Uncurve it. Oh, I don't want to do that. That sounds like so much work. I don't think we have to do that. I think that like unwarping is actually like really fucking hard. I think like beyond the level of which I'm willing to put in effort for this today. But I'm thinking, we have this information kind of like me as a human, I can look at this and be like, that's a line, right? We can also be like, this is a line here, and this is a line here. I think finding like the horizontal edges here, or I should say like these edges, is pretty easy. Like we've already done this before, right? So we don't have to worry about that. But what I'm looking for is kind of like an upper and lower bound of like where we want to average pixels, right? I think that eventually what I want to do is I want to like kind of cut this out like this, right? And say, once we have like this cut out, then we can just say, find me horizontal edges and average like the whole fucking vertical image. And I think that that's like quite doable. So people in YouTube comments keep telling me, just do hue transforms and find lines, which I think is like not like entirely unreasonable. Like I kind of get what they're coming from, right? They're saying like, if you find like a box, you find like these 4 lines here, right? You can like turn those 4 lines into a box somehow, probably, right? I don't really know how you would do that, but I'm like, it's probably possible. And so, I was looking up what a hue transform is. I've looked this up like 10 times in the past, and it like took me a long time to really like get it. I was gonna look it up in lowercase, but looking it up in uppercase is equally good. It's equally effective. And this thing, it's a lot of words to say what is actually quite a simple concept. This is saying, if you have, in a picture, you have a line, right? Not like the concept of a line, but you have like the pixels that make up a line. If you go and iterate every single pixel in this picture, the vast majority of these are blank, right? But some of them have stuff on them. And if you go in here and you say, hey, you know what? Let's say that this point could be part of any fucking line that goes through it, right? Just all of these. And you do that for every single point on this thing, right? You go, oh, these are all the possible lines. What you will find is that all of these points will only agree on one line. One line with a specific rotation and offset, right? So I think that what they're basically doing is they're making like a two-dimensional histogram where like, if you had count number of guys that agreed with like this rotation, right? For this, you would see something that has like a single peak, right? Somewhere where every single pixel kind of like agreed on this rotation of the line, and then you have like another one for like offset, right? And then you just look at like fucking hotspots. So here this is kind of like a 3D plot, right? They have angle and offset as two parameters, and then like the brightness is like how many people agreed on that thing, right? And so they're just basically saying like, pick one. Now, I don't want to do that, right? I don't really think that like line finding and then box finding is really like, I don't want to say like the most correct. I think we're doing like work that is not really, it's not taking us in like the right direction. I feel like you can, because we know that the bars are vertical, I feel like there's some way to leverage this, but like the idea of the voting, right? Of the idea of like building a histogram and finding on which points agree on a thing, that's like a transferable concept that I agree with. I think it makes sense. So what I'm thinking, looking at this, is we could do vertical edge detection, right? And try to decide, do all of our points agree on a vertical edge? Now, that would only work if, how do I say this? If this guy is cropped narrowly enough, but that won't really work if, because the top of the barcode here is like a super solid line, right? So if we were to just say, how many people agree that there's like a vertical edge, that wouldn't give us the right answer. But I think we might be able to say how many people agree that they're on a fucking corner, right? And we should find some Y value that has like pretty good consensus on that. We should actually find several, right? In this world, we should have one line that like agrees on this, one that agrees on this, and one that agrees on this, right? And then we can just say maybe like pick the two most inside ones that are like above some threshold, and that's kind of like our vertical crop. That's what I'm thinking. I think if we can get that today, that would be pretty fucking sick. Do they need upper padding? I assumed so, but that is a really good point. That they might not need it. But I guess we can assume that if we don't find it, then maybe we can do something with that information. But it could, UPC barcode Wikipedia. I have a beer with no gap at the top. Yeah, I'm looking at a beer on my desk that has a very small gap at the top. No gap is crazy. Do they say that in here? I remember seeing something about like it needing space on the sides. Barcode. Maybe just looking up like barcode itself. Maybe UPC is like an encoding of the barcode. Bloop, 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 bloop. Where have I read that they need area around the side? barcode's only one on the left. Like, I'd believe it. Yeah. Okay. So maybe this idea was wrong. Maybe this idea was wrong. In which case, we need something else. They need to have a keep out zone, but if it's only keep out on the left and right, then this idea doesn't work. I guess you could maybe look for the top and bottom of the keep out zone instead. Maybe. Or, I mean, if it's something like this, you do know that like one of the black or white is going to have some sort of area on the top and bottom, right? They can get really cute too. Not sure what they're thinking about. Check this out. Ew. Ew. Fuck those guys. Okay, so it looks like... Ew. It looks to me like the correct answer is actually finding the other way, right? Instead of finding... Sorry, my brain's melting for a second. We want to find, like, the area that agrees that it's inside the barcode. Not on the edge of the barcode. Okay? Which is maybe also doable, right? So let me think about this for a second. So, like, if you were to look at the gradients here, you would kind of know that, like, all of this stuff is, like, 0 gradient, right? 0, 0, 0, 0, 0. Then here you might find some. And so maybe what we want to do is you could build consensus on where this ends, which is the same thing. Right? It's kind of the same thing, I guess. It just means that we don't necessarily have to crop. So we don't have guarantee on corner, I guess, which is interesting. But I guess we should maybe be able to assume that the center of this thing is in fact the barcode, right? I think we should be able to assume that. If we can't assume that, that means our barcode extraction has gone like pretty terribly wrong. So if we just go here and we look for first gradient, look for a consensus on the first vertical gradient above and below, I think that will give us something that's like relatively a good Y crop. Because what we're looking for is like, what are the bounds where we're allowed to average? You could even do something like, you could even just say for each X pixel, where do I think I start and end? And then use that to generate some boxes later when we find the X, because we're gonna do like horizontal and vertical edges. Yeah. Okay. Cool. So to find the top and bottom of the bars, I'm okay with the idea right now of looking for most closest to center horizontal line that has like relatively high consensus. That seems pretty reasonable. So let's do that. Let's do that. All right. Sure. Fuck it. Okay. So let's start by adding a thing to our visualizer. So we are going to have something that we want to look at, which is probably like, the vertical gradient or something. Maybe we calculate the horizontal and vertical gradient all at once now. Extracted gradient, maybe? Yeah, we could do something like this because we are going to need the horizontal gradient later as well to do like this stuff. So we might as well just calculate them both at once. Probably, maybe. I don't know. We'll see. All right. Let's figure this shit out. So we need to display this thing, which means that it needs to have like an image view that is initialized, probably RGBA renderer. We want to render this thing with color because the gradients are going to have like directions. Somewhere we're going to say like update barcode gradient, and he is probably going to come in with a bunch of 2D vectors, I think. And I think we have a function already to do this, to like make gradient to texture. So we can just do this on that guy. So this is the extracted gradient here. Bing, bang, boom. And it looks like we needed some sort of allocator here to make a temporary thing. Okay. Cool. And we need to put this thing in the UI somewhere, so let's do this. We add a widget, which is an image view. What do we call this thing? Barcode gradient as widget. Okay. And can we also do like push widget of a label so we can have words for it? So this is you know, extracted gradients. Okay. Cool. We called this something else. Extracted gradient. Did I spell it wrong? Oh, there we go. Okay. So this should give us like a little label here with nothing in it. Yep. And okay, so now when we update image views, we have some, I think we don't want to apply this blur, by the way. I don't really want that. Because I think that we're blurring as we extract the barcode right now. So I don't think that this blur that we used to do is required anymore. So can we like delete that for a second? And we should just be able to run gradient on this thing. Now, do we have a way to do that easily? In barcode extraction, we have some gradient kernels that we just say this. So I'm just gonna slap a public on this thing because I think that this is still correct. Yeah, and we'll just fucking figure it out from there. Okay. So here we should just be able to be like, barcode extraction, image gradient with the scratch allocator, and we want to put this on the, you know, our barcode image. Boom. Our extracted thing. Oh, sick. Barcode standards. Hype. Christos Tech, thank you for the raid. What's up, you guys? What is up? Yeah, so they're not guaranteeing that you have top and bottom margins is what this looks like it's saying, huh? But there is, like, guarantee on the length. Okay, sorry. For those of you coming in, let's show you what we're working on. We're working on a barcode parser that is meant to be used from my phone in a little web page, right? So the idea is that, like, when I'm loading my fridge with the mayonnaise, I want to be able to, like, scan it and be like, I have mayonnaise now, right? And so, like, part of the idea here is that we want to make sure that, like, it's fast and works in, like, as many scenarios as possible so we don't have to, like, finagle, you know, the camera and stuff, right? So this is our kind of like sample that we've been working with. We do some like down sampling, we do some edge detection, or like gradient calculation, i.e. like how much are pixels changing in any direction. We like look for areas where a bunch of the like directions line up, and we say, hey, if there are a bunch of directions line up, then we're probably a barcode, and we pull that shit out. What we're working on right this second is trying to like compress these bars vertically so that we can do barcode processing on them. We used to do something else. We originally tried to do like line by line processing, and then we were going to say if we gain consensus that all of these guys, every single row in this image had like the same number come out, then it's like probably correct. But we got kind of stuck on the idea that like a shadow can make this like a little ambiguous, right? So we're trying this new idea of saying, let's get consensus on like the vertical pixels first, then render the barcode later. And so that's what we're working on right now is like, if we're going to gain vertical consensus, then we need to like know where the bounds of our bars are. And we're trying to figure that out. So apologies for the quick explanation. We just went over this a second ago, so I don't want to like dwell too much on it. But that's what we're doing. So at this very second, we are trying to visualize the gradients for this image. So this is the barcode gradient. And we should just be able to like shove this into our image views, you know, update the gradient with our scratch allocator and barcode gradient, probably. And this should show in our UI, hopefully, if all this stuff kind of compiles. Anyways, thanks again, Chris Sec, for the raid. Much appreciated. Yeah. All right. So here, okay, sick. That's working as expected. So here we have some image, and it looks like if you were to look for, you know, red means horizontal, green means vertical, and you can tell that we have some, you know, amount of vertical segments, right? Now, we do not want to flag this, right? So what I want to do is maybe, I wanted to draw a histogram of like which y-axis pixels have strong gradients. Maybe just the gradient. Let me think for a second. We might be able to like some gradient magnitudes. Is that what I want? Yeah, so for each y pixel, what is the total gradient for that thing? So for like we will that should account for if it's like a weak or strong gradient, and then hopefully our histogram starts to look a little like curvy. I'm hoping to see like some sort of like up and down around certain like a few y values. That's what I'm hoping to see. So let's take a look at that. So the other day we made a histogram widget, which we should be able to like easily put in here. Should be. So if we go like like y grad hist is gonna be, you know, histogram. I think this is just a widget actually. Yeah, so we make a widget that we have a retriever for. That's the way our GUI framework works. Yes. So I guess that means that somewhere we feed in the y grad retriever. And this is like a y gradient retriever or something, which we need to make somewhere. Okay. Now, this guy, it does not go here. I lied. He goes into our GUI construction. So here, y grad extractor or retriever is a y gradient retriever. Okay, and then we use that somewhere when we want to like make our histogram. So we say this is a y histogram, okay, and we use make histogram using our y gradient retriever. And now all I have to do is define how this data makes it there. Y grad retriever. So presumably, I don't know. There's gonna be like some data associated with this thing. But I don't know how yet. You know? I think that we want this guy to be a pointer, to be honest. Because the data to this thing should be changing later, I think. Like, we're gonna be, like, modifying this guy. And so, having a pointer to the thing that's being modified seems reasonable here. This guy has expectations on functions that he provides that, like, help build the histogram, right? So, like, how many buckets are in this thing? What else is he expecting? I guess we should return 0 here. He is expecting us to be able to make an X label. So like for if we're hovering over, we want to like inspect this thing in some way. So it's like I don't remember what the function was called. We'll see in a second. Get X label. And this is like, you know, we take in an allocator to like make the label on. And I think the index of which one we're making, we return a string, probably. Okay. And index here. Okay. And then I think the other thing he wants is like the y values. Yeah, get y. So this is supposed to return a float from some index. Okay. And then we have our data generation. Okay. So every time that this number changes, it regenerates a histogram. What the fuck? Generation? What's wrong with this? No field name generation in main y gradient retriever? Why not? Am I high? Am I high? Method invocation only supports up to one level of implicit pointer dereferencing. Oh. I see. So here, when we call this guy, we shouldn't be passing the retriever by reference somewhere. Yeah. Oopies. That's better. Okay. Okay, so now we actually just have to like fill out this data. So we can decide now when we're calling like update image views or whatever, we can decide how we want to do this. So I guess here we have this guy sitting around here somewhere. And can we just call like update or like function update from image? Yeah, that seems reasonable. Uh-huh. Okay. And I guess we're gonna go over like, you know, each part of the image. And we're gonna go like for each row. We are going to like, I guess, like initialize some count, right? Something like this. And then we're gonna like go like over each column. And like total gets the y component of this gradient. So it's just like, look at the pixel here. Y index. Okay, sure. And I think that we want some sort of like, you know, we have some allocator associated with this thing, probably. I think, yeah. And we'll say that like, you know, we reset all of our allocations, and then we have the y vals in here as just like a bunch of F32s, right? And then here we say, you know, y vals is nothing in case something goes wrong. And then what? Like, we allocate by how tall this thing is? Yeah, sure. I guess we assign after, so we probably do like, we allocate this memory up front. You know, initialized with our arena allocator here, and it's like image calc height tall, right? You know, new y vals is this, and then at the end of this we say self y vals is equal to new y vals items here, and then for each thing we can just say like new y_vals append total. Easy. Easy. Okay. So now we can go down here and we can say y grad retriever update from image barcode gradient. Hype. So this should make us a histogram, and then we just need to make it so like this. These values are like used. So self generation plus equals 1. I guess this needs, since this is a function, this needs to be like gross generation value. Okay. So now this will indicate that the data has changed if we return that thing. So QR code processing, I've like done that a little in the past. We didn't really finish. We were working more on like with perfect data, how are we going to parse that thing? And we got something that like worked okay. The error correction in QR codes is like a disaster, dude. It's really hard. So I got kind of like hung up on the math there, but probably won't go back, but maybe one day. Like this is kind of driven by like a real problem that I have, so. What is like the X label here? It's probably just like the pixel index, right? I think so. Format alloc print with alloc. We just print the number, I think. I think that's fine. And then the y value is just like y_vals at index. Okay. So here we need to split off our root allocator. You know, we create a sub allocator for y retriever that can be initially cleared. Simple. What else do you want? By default, this guy is empty. And then this guy wants us to pass in y grad retriever here. Whoa, why? The fuck is he complaining about? What's he complaining about? Hello? Try using try? It says try right now. Oh, it's update from image. Doesn't use try here. Is he mad about something else? No function named append. Oh, because I have to write try here as well. My bad. My bad. Then all these guys needs y grad retriever on all of these. Every time we update our parameters, we do need to update the histogram. All right. Let's see if this looks kind of reasonable. Bad news, bears. I don't see a histogram there. Because the histogram tries to fill up all available space and there's no space left. So we need to make sure that we request that this thing has like a certain amount of space associated with him. So I think that we have like a thing that's like widget factory make box using this histogram. But you know, we have some size, so can we just say like width is equal to, you know, 500, height is equal to 500 or something, and then no resizing. Do not attempt to resize to fit anything. Okay, is that better? Oh, hell yeah, dude. Okay, so here we're seeing like negative values, which isn't good. In fact, our thing doesn't even support negative values, but also they're wrong because the gradient direction doesn't matter here, only the magnitude, I think. So we should be, when we try to update that thing, we should be using the absolute value of the pixel value here. And then I'm hoping to see a couple strong points, right? So we're seeing like a really strong line at the top, right here. Then another strong line at like pixel value 16, which I think is like a bit reasonable for here. Then we should be seeing like a big gap until like here. And what's interesting here is that there's actually a lot of peaks, right? Because the numbers themselves have a lot of like vertical as well. So when I look at this, what I'm saying looking for is, okay, so how many pixels tall are we? We're like 310 pixels tall ish. So if we were to like look at like 150, I think what we want to do is we want to look for like a large increase, as we like drift left or right. We might want to blur the histogram itself a little bit, right? Because like we don't really want like noise here. We're looking for like a big change, right? So you could also do something where you're trying to like amplify peaks but like filter out small amounts of changes. Right? Like I'd be worried if you just did like a full-on blur, that you would like squash this peak here, which you don't really want. It's almost like you want to amplify changes, but not like, you want to amplify changes over some magnitude. We should probably assume let me think for a second. Yeah, so, okay, I guess we just kind of like walk sideways and we say, if we maybe take like a rolling average of the last little bit as we walk out, right? And then we say, if there is a large increase from that rolling average, then we like clamp it there. We're totally fine to clamp early, right? Because we should still have like a lot of signal in there. So I think this makes sense. I think that makes sense. Just take the histogram as the image and do a ray in both directions. He's a genius. He's a genius. Just raycast and hit the hill, dude. Okay, yeah, let's just do that. Let's just do something where we go like, how do I want to like visualize this? I guess we just print them and then we can look at them in the histogram and see if they look reasonable. So in reality, we don't really want the totals here to be calculated as part of this retriever, I don't think. I think that that's kind of like a visualization only thing. In reality, we want to be doing this externally. So it's almost like this guy takes in this and then copies them himself. Because like later we're gonna wanna not do it this way. Okay. So here we have like generate, like make y gradient histogram or something, right? And it's gonna return like y vals like this. He needs an allocator to split that shit out onto, and the image gradient. Okay. So that's kind of like this. Right? So he does all this stuff and then just returns this at the end. Okay, he lives on this allocator. Bing, bang, boom. Now here, this stuff goes away now. Okay, and then when we call update from image, we say, y hist is make y grad histogram on the barcode gradient with our scratch allocator. And then we y hist here. Barcode. This thing can fail, true, which means that this can fail, true. Okay, so this should just look exactly the same, right? Bloop. Okay, cool. Everything's still working. Okay. So now we want to do like, you know, y hist len over 2. We're gonna go like for this to y hist len, we have like some index, and we look at we want to like take some sort of like rolling we actually have a rolling average type. That's kind of fun. It almost works for what we want. Rolling average is rolling average of F32s. We probably want like a window of like, you know, a small amount, you know, of the image. Probably. Maybe 20 is too short, but oh, this is also a runtime value. So this type does not quite work for us because he's expecting stack size as well. But it's easy for us to kind of adjust this. Can we just say this is like grad rolling average? I'm too lazy to make this generic right now. Too lazy. Can we just call this like F rolling average for floating point? It doesn't fucking matter. Okay. So what's this guy got going on in him? We want data here. We need to, you know, some init function, which will take in a allocator to allocate the data section from, and a runtime size. Here we're like, you know, data is alloc some fucking F32s, and we return something here. I don't know, man. IDX is 0, used is 0, and data is data. Okay. Then when we push data, we say push to index. We make sure that we've marked that thing as used, and we update the index with a rolling thing. Cool. This guy, we have ret is a floating point because we're not dealing with generic types here anymore. This is like this. And here we don't do div trunk. We just do float from int self-used. Okay. Easy. This is looking kind of right. So we should be able to be like, give me a rolling average of initialized with our scratch allocator. And size. So let's say we have 10. Oh no, we wanted to do y hist len over 20 or something, right? Like 5% of the entire image or something like that. And then we say like, you know, let's push into this thing, you know, y hist I. Okay. And then if, I guess it's like, in this case, we want to know if it's like ready. You know what I mean? You know, and it's like if self-use is equal to self data len. Right, so we're like seeding it for the first few elements, and then eventually we have more. Nomad Wander, thank you for the tier 1, and I am Sivo, thank you for the tier 1. Much appreciated, both of you. Thank you, thank you. Yeah, so we say like if rolling average ready, and rolling average, like we want to do something like, check if it's ready and like the average value is like less than the current thing. I don't know, man. Current, like, we want to say, like, if it's, like, significantly increased, right? So if it's, like, gone up by, like, over 2, over 1.5, right? So we can kind of do this and, like, average, times 1.5. I can just do that here, right? Then we, like, break, and we say, like, max, max y is, I mean, if we never hit this case, then we probably want, like, y hist len here. And then we say, like, max y is equal to I and break. How many standard deviations? Yeah, I guess we could do that too, huh? That's not crazy. Because that, like, automatically filters out, like, noise, which is kind of hype. But fuck it. I don't really want to do that right now. But I do agree with you. That's probably good. Okay, min y is like 0 by default. We like reset our average here. And then we just run this shit again. But like from 0 to this. And we look at min y instead. Seems kind of reasonable. If this is, yeah, same shit there, same shit. And then I guess we just say, like, let's take a little peeksies at what we find. Min y, max y. F32. True. So true right now. This needs to be as F32 here. Okay. This is F32, true. And this needs to fail, which means that this init needs to be tried here. Data len is the answer, not size. Okay, and then this is not an ampersand, because he's already a slice. This needs to be a usize, probably, right? Alright. So here we went 15 to 170. So this is 15, like, here? Hold on, we're supposed to be walking backwards, no? Yeah, that's bad. We should be walking from, we should be doing this. While I is greater than 0, defer I minus equals 1. Or I think we just do this off rip. Because that was the first value here. Sure. Okay, so now we're going min y 139. That's interesting. If the rolling average oh, this is assuming that we start at 0. So when we reset, we need to do index of 0 as well. And then also this rolling average here should be going from 0 self-used for this to be correct, I think. Okay, 139 is still not good. Still not good. So it could be that this is like, I mean, I don't see any worlds where this is like 1.5 times bigger. So this is like, we're doing something fucking wrong here. So can we... I'm just gonna like be very confident here. I don't think this should matter, but you never know. Yeah, 139, 170. Okay. So we gotta figure out why that's happening. Can we just look at like the average and val? True. Average 5.4. Okay, yeah, and then the val is 5.43. So like how the fuck? Like that should not be happening, right? Right? Rolling average, average? Oh, is it the other way around? Yeah, wait, what the fuck? How is this working at all? I don't know if y hiss is bigger. Oh, we were probably looking at like the back end or something of it. That's funny. Okay, 22 to 237. Does that make more sense? 237 is like here, and then 22 is here. So according to this, I think that's right. I think that's right. So let's crop that and see what we get. I don't know if we have like an image crop that, like, it would be nice if we didn't have to copy the whole image. I think that this is doable. I guess X crop with the way that it works is not easy because we don't have like a stride parameter, but lucky for us, we don't need to X crop. So crop Y. Do you want to go past the gradient increase? I think it doesn't really matter, to be honest. I think it does not matter. And this is going to return a new version of self, and we'll just say, note that crop X could be done if we cared about stride, which we don't yet. But I guess it should be like generic crop could be done, yeah. Okay. Data is gonna be self, it's like, boom, boom. It's like self data from start times width to end times self width. And width is just self width. And then that should make it so that we can just do like a basically free crop. So we should be able to be like cropped is I guess the original image, right? So we just want like barcode start crop y from min y to max y. And then we want to display that somewhere. So we have somewhere, we just want like cropped barcode y crop or something. Okay, and then this thing is grayscale. And then here we want to invalidate him when parameters change. Okay, and then we say, what, image views, update, y crop with cropped. Okay. Then we need to like figure out how to do that. So really these functions, this should, if we just did this as a part of the fucking image view, then we wouldn't have to write all these functions. Let's just do that. Well, I guess we don't really know. It depends on like what the thing is, I guess. Like the type of image that we're feeding in does matter here. So I guess we'll do it this way. Fine. Update Y crop takes in an image of U8 and we say make texture from the red channel, please. Of what is this? Y crop barcode Y crop or something? Yeah. Okay. Okay. Fucking for loop usizes in this language. Okay. So does this do what I want? I mean, I guess it does, right? So we're going like, we're cropping above the numbers here, and here we're cropping here. I guess it's better if we could go all the way to the peak here or something, right? So this is like, what do we crop at? Right, we are cropped at 237. Which is like basically here. So it just means that like, you know, because this thing is curved, there's like a few more here, but I guess it's fine. It just means that like, it just means that these values will be ever so slightly lighter. So back to that picture that Urkerstern sent us. This would probably crop like here, right? And so if we kind of did it this way, maybe this is kind of wrong. I'm starting to think that this was wrong, cropping it this way at all. Like, maybe you want to do it per bar almost. Yeah. I guess, like, I forgot. I forgot that that's what I wanted to do. Middle third? Yeah, I mean, maybe, right? Maybe just fuck it. That's not, like, that crazy. It's not that crazy, but I'm kind of down. Oh, also, this photo is kind of blurry. I forgot that like the quality here on the side might not actually be that good. I forgot about that. So can we look for a better one? Like, is that better? I mean, that's still pretty bad. Dude, I just fucking like thought that if I like wiggled my camera around, we would have like some good ones. Though maybe that's pretty good. That might be a little better. That's 177. 176 looks pretty fucking solid too. 176. Wasn't 008 okay? Dude, if you remembered that, you're crazy. Yeah, that's not bad. It's like a little faded over here, but that is a lot better. I think I was happy with, what was it, 177? Yeah, I mean, that feels pretty good. Let's try this and see what happens. I do want to rotate it though, because I think that's a better test. So can we do 177 comes in here, and then we just do a little Export as... All right. Yeah, okay. Bum, 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 bum. All right, how we looking? Does everything else here still work? It's pretty good. That's pretty good. Okay. So we might want to come back to the idea... Dude, are those really slanted or what? I actually can't tell. I guess what we should do is, it could be that our, like, tilt detection is, like, a little bit off. I hate how I have to do this twice every time. Like, how far over are we going? This is like 800, and this is like 814, so it's like 15 pixels off. So maybe this idea of like vertical averaging doesn't work until we get a better answer for gradient direction. Or yeah. Okay. What if I think that this is fixable. It's possible that it's because we are doing our initial gradient detection at such low resolution. Like, if we increase the resolution of this guy a little bit, where the original gradient comes from, then we have to increase the downsample factor because this guy's working on like pixels. I don't know, that's still like seems pretty tilted to me. So maybe that's not it. It could also be that like maybe we should be I'd be interested to know. We might need to look at some histograms of like the gradient values here. I'm trying to see. I think that it's improvable, so I'm hesitant to change the approach here. I do like the idea of using vertical information here, and I do think that we can get a better answer. So doing like another rotation here is not ideal. I don't want to do that. So I'm trying to think if we can like dodge that problem for a second and then come back to it. You know? Sorry, brain. Brain melting. I'm curious to know if I rotate this back, if the answer's better. Right, like does it depend on the initial rotation here? Why the fuck is that failing? What the fuck? Export to 177? This worked fine? What the fuck? Rotate it back? Oh, maybe this is just taking forever at the bottom. Alright. Alright, we're chill. So does this, like... Yeah, whatever, I guess. Also, why... Something about this looks wrong, no? Oh, I guess it's just got, like, a really tight crop. That's funny. And then can we just not rotate it? Um. I think that if we say that our box params here, we just like hard code this to horizontal, then I think it fixes itself. Like for now. For now. Just as a hack. We're hacking, because this can be fixed. Box params new x is equal to 1, 0, no rotation, and new y is 0, 1. And just say hack workaround because I don't want to fix this right now. But I think it's fixable. All right. Cool. Cool. Okay. That's looking pretty decent. Pretty decent for now. Good enough. I think it is also that there's some warping here because it's on a curved surface. Like I can tell that like the tilt of these bars are not the same at each x-axis. So maybe that's actually going to be a problem. Oh, so the answer is to like fucking flood fill? I guess that's the answer, right? If we can't rely on them being perfectly vertical, if we can't rely on them being perfectly vertical, specifically because of like the warping of the container. But how then can we like determine their width? Right? If we're trying to compress all of this down into 1 pixel vertically, it means that like I guess we have to walk like the shape that we are seeing. We like start on the horizontal and we walk up and down on that horizontal until we find like a vertical edge. But like with adjusting of x in case the thing is tilted a little bit. Yeah, that seems doable, right? So maybe it's like something like we're assuming the center is in code, right? So if you have something that's like slightly tilted, you know, I guess you walk for each pixel that you walk up and down, you look left and right to find the width, right? And you recenter yourself on your bar every pixel. I guess that's the play, and the stop condition is just that like you hit the end or one of these vertical gradients. So like maybe just fuck this whole idea of like cropping the image off rip. I think that works. I think that works better. And I think it's like not really any more expensive. I like that idea. So we'll kind of say new plan. New plan. Yeah. So if we say okay, so also fuck this hack now because we don't need it. Okay. So we're going to go hold on. It was update image views is where this is living right now, which is the wrong spot, but you know, whatever, fuck it. So like start at center. So we go like for each x pixel, we have some like output image. Blup, 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 blup. Let's think. For now, just so that it's easy to visualize, I'm gonna make this like 50 pixels tall or whatever. This is like wrong, but whatever. We'll deal with like data formats later. So let's say like, you know, extract like vertical compressed is going to be a new image, maybe of bool, but probably not. We'll probably do that step later. This is allocated, like initialized with the scratch allocator. And his width is going to be just kind of like the barcode width. And his height is going to be 20 or something, just so we can see it. Then for each X position, I guess we have like out iter. We probably actually want to do like an area iterator. So center, we're gonna start at start x0, whatever our parameters here. Start x end x. So this is barcode start width. And the y, we're just gonna look at the center pixel. Image view. Nope. Barcode start. Calc height over 2. Barcode start. Calc height over 2 plus 1. All right. While we are iterating this thing, next pixel or something, we're gonna look. No, this is stupid. This is stupid. What the fuck am I talking about? What the fuck am I talking about? This is stupid. We're gonna go iterate the whole image. While we can iterate column, that's all we need to do. So we want to say like center is our like input image. Okay, and height is, you know, barcode start, I guess like this. Okay. So for each output pixel, you know, it's like X is wherever we are in this thing, right? But this is going to move. So we go for while X, while Y is less than max Y, I guess, in this scenario. No. While Y is less than the height of the entire image. Because we're not doing this crop shit anymore. Fuck that crop shit. Fuck that crop shit. We're calculating like the average pixel value, right? So I think something like this. Who fucking knows, man? Who fucking knows? We like center X here. Maybe. We like walk backwards in X? I don't know, man. I don't know. Something like this, and then we say like if has edge has vertical edge at this position, we like break, right? Something like this. Something like this. Something like that. And then while we're doing this, we're looking for like the min-x. Are we? Yes. And probably we're also like adding to the total, right? So, yeah, dude, Jesus Christ. Right, it's like some absolute bullshit like this, right? So it looks to me like we want to start, how do I say this? Like make like some sort of like proper iterator out of this guy. Because this is going to be really fucking hard to track. So can we do like something that's like bar iter? And we also somewhere we had we need to like also have like a proper edge detection here. Let's start there, because without horizontal edges, this whole thing won't work. So can we do a proper horizontal edge detect? We did this somewhere. Edge pass 1. We've done this before. So this guy takes in an image and returns an image I32. What is I32 here? Edges. All right, let's just see what this does. Well, we need to like figure out how to visualize this. So I32 here is gradient average. Okay. Oh, I see. So this is generating a gradient, which we already have. So we don't have to do this part. Yeah, because this average is over once. This average is doing nothing. So we just already have this. Then we have edges 2, which is doing kind of like this stuff. So he's walking over the image gradient, and he's checking if we have a sibling. Ah. Yeah, wait, what was he doing? So this is like merging edges. This is saying if we have a nearby gradient, fill in a hole. This is hole filling on an edge, which I don't know if we really need to deal with right now. We probably do. Oh, this is why I fucking wanted vertical edges before. It's because there were holes in the fucking edge detection, and it was nice for us to be able to, like, actually, yeah. It was nice for us to be able to fill those holes somehow, which is starting to make all of those people who were talking about, hue line detectors, they're all starting to sound a lot more reasonable now. They're all starting to sound a lot more reasonable. Okay, I'll give it to him. I'll give it to him. So, okay, so we must have somewhere. Okay, so we at some point had like a canny edge detector. We kind of modified this a little bit because the canny edge detector is expecting you to have like horizontal and vertical edges, which we don't really need. So what did we do instead? I don't seem to see it in there. We find potential edges and we suppress weak edges that are not connected to strong edges, and gradient magnitude threshold and a lower bound cutoff. So I think it was like we look for if a gradient is larger than all of the gradients around it, was is my recollection here. So compare the edge strength of the current pixel with the edge strength of the pixel in the positive and negative gradient directions. If we're the largest compared to the ones beside us, then we are the edge. Okay. So I think I might be on the side of hue detector people now. So we can still work off the idea that we only need horizontal edges, right? So the way we turn this like gradient, which might look like this, where like, you know, the gradient starts going up and then down, it's actually probably more like this. No, it's probably like this, actually. Yes. So if you have like a, you know, I guess this is like the pixel value, right? So as you go left to right, if you're going like bright to dark, it's kind of like a smooth transition a little bit. Like there's going to be some amount of blur there, right? So I guess the gradient is going to look kind of more like this, right? So it's going to be like, it's going to start going down, then go down for a little bit, and then stop going down type shit. And I guess this is actually kind of be like going to be like a little bit more like this, a little U-y. So we're looking for like the maximum gradient is where an edge is. If we see, you know, the peak of this gradient thing. So I guess what we want to do is we want to find these edges, which is easy, right? So let's start there. Let's start just marking edges without trying to like hole fill or anything. And then we can try doing like sorry, my brain. We'll figure it out. We'll do, like some sort of like hue detector style thing to figure out the direction of the edge. And in reality, hold on, brain. I'm not convinced now that we have to do this on rotating anymore if this is the path we go down. But we'll see. We'll see. Okay, so we have our horizontal gradients. That exists. So all we have to do is look for areas where it's bigger than both the guys on his right and left. That's what we're looking for. Okay, let's start there. Edges. This is going to be a thing that just matches barcode size and we're gonna say if I don't know, man. Edges iterator. While IT next pixel, we check if the like barcode gradient pixel like to the left and to the right, right? That's all we look at that. Right is this, but we need the minimum of this and, you know, barcode gradient width -1. Okay, and then we say like if, IT, the barcode gradient pixel at XY, 0 is greater than left 0, and I guess we have like us. If us is greater than left and us is greater than right, we probably need to handle, you know, the fact that they might be the same or something. Probably, I don't know. edge IT pixel is equal to 0 or equal to 1, 255. Else IT pixel equal 0 or something. I don't know, man. I don't know, man. Then can we like render this thing? I just want to see what it looks like. I just want to see what it looks like. Barcode X edge. Boom, boom, boom. And the rest of this, I think this works fine. Okay. Barcode X edge. I just want to see it. It's not in the fucking UI. It's not in the fucking UI. X edges. Alright, let's try that again. Not good. Not good. Probably because we're not calling it, huh? It's probably related. Probably related. If we want to see it, we gotta look at it, you know? Okay. Promising to some extent, right? We also have to threshold this, right? I forgot. If us 0 is greater than 20 or whatever, we must have had some threshold here before that we used last time we did this. Yeah, it was 20. It was 20. Too high. Can we... Maybe it would be good to look at this stuff, but what if we instead just fucking randomly pick numbers until it worked? Thoughts? We probably want abs here as well on all of this stuff. Actually, because we don't care about the... We only care about the magnitude, not the direction. And in reality, we should only be looking at x-axis on all of these to begin with. So if we're going to be doing calculations, we shouldn't be doing them on stuff we're not going to use. So there we go. Let's try that. Let's try that. Really? Nothing? Okay, so 0, great. 1? It's crazy that 5 was too low. So, like, what are these values? Oh, these are fucking floating point now. Not pixel. I'm a dumbass. I'm a dumbass. So these are normalized 0 to 1, and I forgot. They're directions. There we go. So that's at least, like, semi-reasonable in terms of, like, edge location. Right? And we can now use this to, like... Let me think. So, we had holes in here before. That was the problem. That was the problem. And so, if we want to make, like, not slide through holes, we can do line detection. That's definitely an option. Or, or, is there another option? I mean, it's not that bad, right? So we just build like a histogram, like they say in the hue detector thing, right? Hue transform Wikipedia. So they say like represent lines as, you know, distance from center and rotation. And between those two parameters, you can build like a 2D histogram like this, and then you can reconstruct the line at the end. So The question is whether, like, you could reduce this complexity by doing what we did last time, actually. What we did last time was actually good enough. So let's start there. What we did last time was we just filled in holes. Right? We just said, if there's a nearby gradient, then we use that. Wait, is that true? Yes. I think. Yeah. So, for our case, where we're trying to iterate outwards until we hit an edge. Hold on, we're getting somewhere. Yeah, I think it's fine. I think that we can walk up and down, adjusting our X position for if there's like wherever we're centered. Make sure we fill holes from the parent from if there's. Yeah. Okay. I think I've got something. So we go. If there is a hole here, just theoretically, right? Say we're like this. We walk right until we see that either here, or here has a pixel. Then just give up. Then just like stop iterating. Yes. Okay. So we're back to making this like barcode iterator. So we start with like, start pause is like, I guess, I don't know, start X. We have some position that we start at. We have like some sort of like maximum that we don't want to go over, right? So like max X is going to be like the image width. And max Y, I guess it's like image width and image height is the thing to put in here. Okay. We are going to reference the edges thing. Image bool here might make more sense, but fuck it. Are you almost always intuiting brute force algos? Are you not scared that might be like other solutions that have some well-known math? But that's not the fun. That's not the fun. The fun is coming up with the solution ourselves, right? We can like, once we have something that we think works, then we can like, look for problems with it. But I think that like, it's looking is cheating in this world. I'm not really trying to make like the most efficient thing, right? I'm just trying to like make a thing that's like good enough. And I think that like exercising the brain muscles by like doing it ourselves is like valuable, right? And so it's kind of just like, I think about it, try a thing. If it doesn't work, that's okay. We'll do something else, right? Like if it doesn't work, it doesn't work. And I think that that's like worth exploring, right? Because like if you look up an answer, you don't get to find all of the failed solutions. And I think failed solutions are like an important part of learning, right? Like you get like a really good intuition of the problem if you try a thing and it like, how do I say this? You thought, you being me, you me think that something works based off of like a current understanding of the problem, right? And if it doesn't work, then that means that like your previous mental model was wrong, right? And so like it's important to me to try things that you think will work, because if they don't work, then then your model's wrong. You need to fix the mental model to be able to make good decisions. That's like basically why I like doing it this way. Then at the end, then we can like be like, oh, I have a problem that I want to solve. Let's look up answers to that problem. And that's like a different thing. You know what I mean? So that's why. Okay. So then we have like my current X and Y. Why U31? Somebody asked earlier too. It's because we sometimes represent stuff as I32s, and so a U31 is just like the unsigned number that fits in I32 space. So we just do it that way. These are like these are actually just like U32s in the machine, but Zig will like stop you from assigning things that are out of bounds, And it's just convenient. Convenient. Okay, so as we're iterating the bar, we start at the center. So I guess we have like stage as well, right? Which is like center up or center down, right? We're going to go through both of these stages as we iterate through the bar. Yeah. And so this is initially, like, it doesn't really matter, right? It doesn't really matter. We are going to step this guy, I guess. This way of working with iterators, I kind of liked it last time we did this for the image iterator stuff, where like we'll just like inspect X and Y ourselves. And so like what are we doing here? We're saying like switch on stage, right? If it's center up, we go step up the streets, right? That's a movie. Step up the streets. Yeah, step up to the streets. We step up, and if it's center down, we step down. And here, I guess if we actually try to step up the streets, if we like succeed, we return true. Otherwise, we switch to center down. We are now we like reset. So we say like self x equals start x, you know. We reset and start going down. There we go. And then here we just return self step down because if we can no longer step down, then we're donezo. Hood iterator? Is that a character from Step Up? Or is Hood something else? Your reference went over my head, which is unfortunate. It's from the streets. Oh, of course. I'm sorry. Obviously. My bad. Of course. Someone's putting bang age, bang location. I guess I'll put bang sex in there too, just to like really finish out the like early 2000s ASL. Dumb shit. Okay, so if we're stepping up, it's like if I guess within up and down we also have left and right. Right? Because we are stepping outwards to find edges horizontally. So I guess we have this is like the vertical stage actually. That's funny. And then we have like horizontal stage. I guess. Center right and center left. So we start going right. And so I guess on both of these guys, we're going to be like step horizontal, I guess. I don't know, man. It feels like this is where this is going. If we are good, we are good. Otherwise, we need to like maybe we can just do that. No, because if we fail to step horizontal, we need to like increment up or down. So self y plus equals 1 here. And then we say like if self y, we need to handle like if we're out of bounds here. So I guess it's kind of like this, right? If self y, I guess the step up is going down in pixels. So I guess it's like this. Yeah, like this. So if we have wrapped, then we have no more upwards movement to do. Then we do horizontal steps. Then if that fails, we like go up by 1 and return true. Then on next iteration, we'll return false. I think that's right. Is that true? No. So in this case, hold on. Hold on. So we're going like bar. We're here. We're going right, then left, and then we try to go up back to the center. Yeah. So, but then like we need to check if we're out of bounds somehow, right? Yeah. So what's the question is after each step, what is the expectation? This returns true if in a bar. If yes. If still inside bar. So first step shouldn't move. Which means that like yeah. Okay. We'll figure that out. Okay. So, we I'm thinking. So, on the first step, we don't want to move. Or X and Y need to be off by 1. Init to start X minus 1, start Y minus 1, or something. Maybe just start Y, I think. Because then we will start stepping to the right initially. That'll be the first one. We'll end up in the center. Okay, cool. So then, if step horizontal returns false, that means that we need to move up. And then here we have to do this check again, I guess. Yeah, right? But that seems a little silly. Can we just ignore that part? Can we do this check down here? Maybe. Maybe. Yeah. I guess you can do something like this. Yeah, you can do something like this, I guess. Okay. I'm not like super happy with this, just for the record. But it's okay, we'll figure it out. Okay, in terms of horizontal stepping, and I guess here we need to reset this horizontal stage. Yeah. Probably something like that. And then we also have to recenter. But we'll figure that out. Okay. In terms of horizontal stepping, we're going like you know, if we're at max int or This is equal to uh this. We are donezo. If that stuff is not true, we're supposed to like increment x by 1, but then like check if we hit an edge. I don't know. Yeah, we're missing. I'm really like missing some stuff here, but we'll get there. Uh, yeah. If this is greater than that threshold, then like we're fucking in trouble. Yeah. Okay, I think I understand. We need like increment x. Okay, we're getting somewhere. We're getting somewhere. So, I guess we can do this. Self x is equal to the minimum of self x plus 1 and the like image width. Okay. That makes sense. So we step horizontal. Then we say if we're out of bounds, fuck off. Or if there's an edge pixel, fuck off. Otherwise, return true. We're good. We're good to go. Okay, now this depends on which way we're going, right? So, horizontal stage, if we are going center right, we do this. And I guess it's actually this goes here. If this is the case, then we want to like rerun with the stage on center left. Right? Yeah. How do you do labeled switches again? Like, do you do this? Is this how this labeled switch shit works? Something like this. Wait, I think I'm getting somewhere. We're getting somewhere. Zig labeled switch. How does this work? State here. Then they say continue with state center left. Okay, wait. I think I'm really starting to understand now. Okay. If this or is edge is x edge. Okay? Then we're like, okay, we're out of bounds. Let's try going left now. Then we try going left and we're like, x is a saturating sub. Is like if x is greater than 0, x minus 1, else, some sentinel value. Okay, yup. If x is equal to max int, or is x edge, return false. There's nothing left to do here. We've iterated all the x values for this section. This makes sense. This makes sense. Otherwise, we're like fucking good and we return true. Okay. So now when we step up, we're like finished the row if this returns false, right? So here, I don't like this. Can we make up go up? If y is less than image height, we add 1 and reset the horizontal stage. Okay. And if we have gone out of bounds the image, we're fucked. And are we also looking for a vertical edge here? Probably, right? So return this or self is y edge. And then here it's like if self y is greater than or equal to self image height, we just return false here unconditionally, and then this is always going to happen. That's looking pretty good. Yeah. This is starting to feel pretty reasonable. Okay, so step down is the same thing, but towards 0. So if y is not equal to the max int, return false. If we can step horizontal, we're good. Minus if self y is equal to, you know, if self y is greater than 0, self y minus 1, else did math max int u31. I guess this is only going to happen if this passes, which means that we can just do wrapping sub. I think that works. We reset horizontal stage. And we return this is backwards. Return this has to be inverted. I think. Yeah. Which means that this is like this. If y is not max int u31 and y is not an edge, then we're good. Otherwise, it's time to fucking continue. Okay. That feels like maybe right. Maybe not, but also maybe right. So now we go back here. So if we can step up, then we're good. Otherwise, we continue with center down. Yep. I mean, that's like not definitely a no. We just need this like is x edge and is y edge. Good, dude. I'm glad that we split this out because if we didn't, we would be fucked. This is complex iteration logic for sure. Okay, so is x edge is just looking for self edges at self x self y. This is pixel is greater than self thresh. And we do this for y as well. And then threshold is just like this. Is y edge? I'm not convinced. We might want to do like, we need to look like adjacent to us as well, right? in case there are holes, like we were talking about before. So we need to be like, y, like x start is, we're looking like for hopefully within 1 pixel, right? Right, something like this. And then we need to like saturating sub this and min this with self width -1, probably. Right, something like this. And then we go, well, also this isn't centered. Right, so if we're like iterating this bar, right, if we're here to here, the x value is like changing. So we actually want like current center, probably. I guess like as we're iterating horizontally, we're supposed to be like logging the maximum and minimum values, right? Right? And then we're supposed to be updating the center based off of these. Right? So like on horizontal, we're supposed to be like, row max x is equal to the max of, I guess it's just equals x, because we know we're going right. And here it's like we know that the row min x is this as well, right? And then, so here we should be like resetting x before here. Right? Which should be like this. Something like that. Which maybe should just be done here. That's not crazy. Yeah. Sure, so that's like handled by the horizontal stepping. And so now, once like this thing is returned false, then we're like in like a good state here to just like check is y edge in each of these cases. Seems kind of reasonable. That seems pretty reasonable. Okay, so now this is fine, right? Because like x has been reset to the center at this point. And so I guess we just go like for x start to x end. We say like if this is greater than the threshold, return true, and if none of that has happened, return false. Okay. And so on x edges, we're supposed to be doing the same thing here, where we have y start is self y -1, y end is, +1, but like clamped to image height -1, probably. And then we're looking at like the same shit here, but looking for y here, and then we have self x here and y here, looking at x edge here. That seems reasonable. That's like a maybe. That's a maybe. Okay. And then how do we check if this works? Right? Because this is a lot of code. I have no fucking clue if it's correct. Right? So I think what we want to do is we want to create an image where we just fucking paint it red. Yeah. can we just like paint like everywhere where we iterate red and just see if like the first segment is looking correct? That would give us a pretty good clue. And then maybe we do it twice and figure it out from there. We probably also we need to jump forward. To the next edge pixel after this. So like, yeah, we'll handle that later. But we should we need to do something like remember how far to the right we are in the center line. You know what I mean? Because we're like iterating right before that. Something like that. But for now, let's just go like you know, flood fill is basically what we're doing at this point, which is kind of funny. This thing is going to have, I guess, the same size as the barcode. That makes sense. And we're gonna say like bar iter, which I haven't really figured out what goes in here yet, but it seems important. Okay. So we have like start X and start Y seem obvious. This is 0. Start Y is going to be, you know, height, like barcode calc height over 2. Something like this. I don't know, man. I don't know. You can't fucking make me understand. Image height is, I guess we do this. Okay. Image width is width. Okay. Edges is edges. We seem to not have Y edges here, huh? These edges are only width. No Y edges yet, lol. Ignore it. We ignore it. Threshold, X and Y. Y is center Y or something. Row min X is 0. Row max X is 0. Okay, and then LOL, oops. First step will go X equals 1. I guess what we need to do is when we're stepping right, we need to support wrapping back around. Which just can be done like this, and then I think this all works out. Okay. While we step, we set, let's print where we are. Because we're likely going to iterate forever. Just seems like the type of shit that we would introduce. And we set flood fill pixel is 255. And then I just want to visualize the flood pixel, the flood fill. And we'll figure out how to like do it better later. Bow, 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 bow. Update flood fill, flood, fill, boom, boom. Cool. Okay, flood, fill goes here, and somewhere we shove that into the UI. Okay. This is going to, you know, freak the fuck out, but it's fine. We can figure it out later. Let's just see some behavior and then get mad at it when it fails. That thing was a U size, has to be U31. What's he actually mad about? Yeah, true. True, that thing is not what I want it to be. That threshold thing is not relevant because we pre-parse the edges. Oopies. Okay. Why is this not doing anything? Hello? I guess we probably fucked this up, huh? Yeah, he just doesn't iterate anywhere, so we fucked this up somehow. Okay. I guess we should just GDB, huh? It's the easiest way to do this. Step. Alright. Why the fuck are we in center down? Shouldn't we start in center up? Shouldn't we? No? Okay, well, we did expect center up first. Okay, then we're stuck at 6,155. Okay, so what's going on there? I wanted to breakpoint here and then run it. Okay. So 0, 1, 2, 3, 4, 5, 6, 6, 6, 6, 6, 6. So here, presumably, we are in step up loop. And we are getting to the point where we are hitting an edge, right? We must be hitting an edge here. So step horizontal must be returning false, right? Or, at the very least, yeah, it has to be, right? We aren't calling reset X here, which is bad. That was, like, the whole point. Okay, so we're still getting fucking stuck there. Can we, breakpoint here again? Okay. Step. Okay, so vertical edge stage is center up. Okay. So in step up, we get here. So here we're chilling. Oh, interesting. Okay, so step horizontal is claiming a success here. So here we're going, center right, which makes sense. We're like slamming up against the right wall here. Okay. So, whoa, why are we at 2? Oh, my bad. My bad. Okay. Let's go through this again. We were not where I thought we were. So we are still in step up. Horizontal is going here. Where we actually get to 7. Okay, that's interesting. Is X edge is returning true? So we go, yep, we're an X edge. And so we're like, can we go fucking left now? But we don't reset ourselves back there before we get there, huh? Here, we're supposed to be like self X is equal to self center, like... Yeah, this is a problem. We want to do something like this. Yeah. Because here we need to reset to self-center X. Then now we should also set like horizontal stage as center left here as well. All right, let's see if that does anything. We'll figure it out. All right, let's see now. So now we go 1, 2, 3, 4, 5, 6. We find an edge, presumably, and in reset, we're freaking the fuck out. Why? Why? Yep. That would do it. That would do it, huh? Okay, hold on. So we can wrapping sub here. Else this. No. I guess it's kind of like this. All right, let's try that. Okay, so we're still crashing. True. Because fucking X is invalid. So, shouldn't that not happen though? Because is self X is equal to this, so this shouldn't fucking happen. Unless this is getting like double called. So maybe this all goes in here. Wait, I'm a dumbass. No, this should. I guess like technically this should only happen if self X is not equal to this. Otherwise, it just stays at max int. Okay, yeah, that makes sense. Okay, so why are we fucking crashing still? Integer overflow again. Why? Fuck you. Oh. So true right now. There we go. I think that fixes it. Maybe. Okay. Wait. Huge news for us. So we got from... I guess we'll see. Look at the picture. Why is the picture showing nothing? We should be seeing like some shit on the fucking corner here. Probably because we're not actually fucking calling the function to put it in the UI again. Seems like an important piece of this puzzle. That's interesting. We need to MM set to 0. So it looks to me like we only went in one direction. Right? We went down from the center and then across. Now, the across might actually be reasonable given this picture. Maybe. It's hard to tell if these edges extend all the way down. ISIS. Yeah, I'm not really confident on that. It does seem like we're getting way too fucking far. But, like, only after, like, pixel 300. What is the height of this guy? This is, like, I see log here. Edges, size. Alright, what's going on here? $311, okay. So it's just like the bottom couple pixels, there are no edges. Oh, you know what? Hold on. I think there's a good chance that, like, we're running into, like, transparent background, and that, like, is actually kind of reasonable. That's, like, very possible. You know, like, if it just, like, is cropping a little bit around. And that will never happen in real life. Okay, so that's interesting. Where is this happening? Extract cluster from image. Whoa. This is new. Okay. That's not good. What is going on here? Yeah, that's a problem. Sample point is, so the box is, like, somehow off the screen, and that's causing problems here. That's fun. Okay, so... Okay. What is happening here? So this is on resize. This area iterator just needs to clamp this shit, I think. But this int from float is, like, negative. So area iterator needs to take an I32s here, is the only reasonable answer. And then these don't have to get cast anymore. And then that should kind of, everything should, like, just kind of work for free. We're ooming for some fucking reason. 340. Yeah, that's weird. I guess if this is, like, insanely large. What the fuck? Like, what is happening here? Great. Love that. Love that. All right, what's going on? Fucking debuggers, man. 256 by 144. Oh, 512 by 5156 is crazy. That's really fucking big. Where's this coming from? Barcode start is 5156 tall. That's impossible. What is going on? So the like thing that we extracted here is like unbelievably large. Like unbelievably large. What in the fuck? Is it the bounding box that we're getting is just like fucked? What is happening? Does the transparent part at the top cause problems? Yeah, I guess it could, maybe. So here our center is like... Okay, width 5, height 50. Yeah, I mean, that makes sense. So this is causing... This is getting really big when we upsample back to the full res image. But like... This is like 32. Okay, so what's happening here? Where is this coming from? Why? Okay. One of these guys must be like going out of bounds or something. What is like the size of this picture? I wonder if it's just like taking like the full height or something. Could be. Gradient size is this by this, which is like gradient width, gradient calc height. We want a new line on there. So this is an 85 by 48 gradient. And so I guess 50 is like a valid size in here. If the rotation is kind of high. Which it is. Right, so this is a box that is like... We have like an image like this. The box that we're getting is like this. And he's like really fucking tall. And so theoretically this is like a thing that could happen. And then we're trying to like get a really big image. And then we're ooming trying to like get there. Now, it shouldn't be that high though. Like somehow the size that's coming out is unreasonably high for the source image. After all of this, right? So we're multiplying this by like the downsample factors. And like, when we get back up, I think this thing is like mega big. So we're going from like, oh, even this is fine, right? This is like, what are these numbers? This is times 10 to the 2, so 125 by 1000-ish. So then why is that, what the fuck is going on now? Oh, and then we're fucking blowing up even bigger because we're trying to make the width a specific size, and the height is so fucking tall. I see what's happening. Okay, I want to look at what the fuck it's doing, which means that we need to actually succeed on this allocation for this to fucking work. Which is a little annoying, but I think that we can just kind of bump our scratch size, and then, I think that we should be able to get something that at least works. Okay, So what the fuck is going on here? Yeah, I see. You were right. The transparency at the side is causing problems because, like, that's like blowing out the gradients, probably. Right? Like, this is like somehow winning the search. I'm surprised that this doesn't even get a cluster, but that's funny. Can we just do this? Image crop. That's funny. That's funny. Oh wait, did we export? Yeah, okay, there we go. Oh, but this thing is expecting some like ratio of the entire image. God damn it. Can we just bring this up a little bit? Okay, god damn it. 4. Everything's so hard, man. Okay. Cool. Okay. So this is making the flood fill look approximately right. It's kind of running into this edge, but he's only going down. Ah! Fuck. Okay, it's okay. We can do this. We can do this. So this guy goes uppies now. We just need to make sure that this, like, flood fill, this guy is not correctly advancing to the center down thing. I mean, he must be, but like, let's see. I guess we just have to like fucking, breakpoint here, I guess. Because down is up. Because down is down in number, not in pixel position. Because top left is... Okay, so it looks like we only run that one time, so we're immediately, like, getting out of that shit. Okay, Y is 273, so that seems fine. Oh. I had this condition backwards. I had that condition backwards. That'll do it. Okay. Okay. I mean, that flood fill does look kind of like it's working. The outside is white, so it is possible that it is leaking out the top here. It does. That is correct. Now, can we just pick an arbitrary location here? Like, I want to pick, like, here. Which is going to be hard to guess, but we can do it. Okay. So here, can we just, like, pick a start X of, like, 50? And then my X starts at 49. Center X, 50, 50, 50. Then I think the rest of this kind of works. Okay. Good news, good news. So that's this guy is like correct according to this. Now this gap here is like really large, which is bad. It means that our threshold is too low. I think it was 20? No, 0.1? Yeah. Or too high. Wait, we're getting somewhere. Maybe. Oh, yeah, look at that. Look at that. Okay, Then let's try to get this black section here. So like 50, maybe double it in half. So this should be like double and a half is 125. Dude, iteration's so fucking hard. Oh yeah, look at that, baby. So this black bar, we like have this bad boy now. So that's pretty sick. I think that these edges in here are like they're too many of them, for sure. So we might have to work a little harder to get these edges to be a little bit more consistent. But there's something here. There's something here. Okay, so what did we learn today? We gotta stop. But like, what did we learn? We learned that our initial plan of cropping the barcode top to bottom does not work because of shit like this, right? This will happen. So we tried basically like finding the edges of a bar, but based off like a really like stupid heuristic where we just like do horizontal gradient and there was going to be a bunch of holes. We were initially thinking that we could get away with just like expecting vertical edges, but because I originally thought that like we'd be able to rotate the barcode into a position where you could always get like a perfectly vertical edge. But because of the like mayonnaise bar, like the mayonnaise container that we're looking at is like round, it means that like there will be warping. Right? So because of the warping, we can't rely on a perfectly vertical edge unless we found a way to like completely unwarp the thing, which is like unreasonable. So I think all of this is to say, the people who said fucking just use hue thresholding, I now think they were right. Or so all those people who said just like fucking do lines, I agree with them. So I think that for next stream, we'll just do what they all said. I'm on their side now. We need to basically say, for every center pixel, for every pixel along the center of the x-axis, let's actually try to find lines that are agreed upon by many edges, right? Which we will be able to figure out. And then we can do the flood fill strategy of like saying, for each pixel in here, like flood fill your area, and then like take the average of that and use that as your pixel position or something like that, right? Your pixel value. Well, like by flood fill, I mean like walk this whole area and average out the value or something. I don't know. So yeah, we'll do that tomorrow though because it's 4:30. Thanks for watching, guys. If you like what we saw, we stream most days 12:30 Pacific time to 4 o'clock Pacific time. It's 4:30 now. So anywhere between 4 hours ago and now, or half an hour ago is when you should expect to see us live. We're working on this barcode scanner. We're exploring a lot of things, right? We're doing stuff that is stupid. And that's part of the process. It's intentional to be stupid, right? Because it means that we get to explore all the reasons why things don't work, and the next time we'll know. It'll be in our brains for later. So it's good that we suck. But yeah, if you like the stream, please consider supporting. Some content of some portion of the streams end up on YouTube, usually like the 2 to 4 section. But some portions do not. It really depends on if it's like something that I think is like titleable, algorithmically friendly for the YouTube, and all that. But the other stuff goes up on Patreon, Twitch, and YouTube member segment. We do that because, we want to give something to the people who contribute or who support the stream. The stream will stop happening when I run out of money, so, it's a little incentive for you guys to show support if you want more stuff and if you want more stuff long term, so that's the options. Yeah, I don't know if we'll stream tomorrow. We might skip. We'll see. But anyways, YouTube, peace out. And Twitch, let's find someone to raid.